Hi, I'm Chris, and in this physics lesson we're going to take a look at an application of Hooke's law, which is a law that helps relate the force to the displacement of a spring. So let's take a look at this question. A person steps on a platform connected to a spring with a spring constant K equals 120. If the spring is displaced 0.5 meters, what is the mass of the person? So let's take a look at the scenario being described. We have a platform that is attached to a spring, and a person is stepping onto that platform. Upon doing so, this spring is going to be displaced 0.5 meters. So this person is pushing the spring down 0.5 meters. And we're told that the spring itself has a spring constant of 120. So now we have to know Hooke's law to be able to relate these values to each other. And Hooke's law tells us that the force is going to be equal to negative kx. So let's talk about what this means. Force is a concept that by this point in physics, if we're doing problems with Hooke's law, we're hopefully familiar with the idea of force. If not, you might want to go back and look over Newton's 3 laws and make sure that we have a basic understanding of force before we try to tackle a problem like this. But if you're ready to move forward, we'll take a look at the other parts. K, as mentioned in the question, is spring constant. And basically what that means is how stiff a spring is, how difficult it is to stretch or compress a particular spring. So for example, a slinky would have a very small value of K. The shocks on a car would have a very large value of K. They would be very hard to compress. And then X represents your displacement from equilibrium. The negative sign is also important here because if we're not careful with how we utilize it, it could negatively affect our calculations. The negative sign refers to the fact that this force of a spring is always a restoring force, which means the force is always applied in a direction that attempts to bring the spring back to its equilibrium position. So if I have a spring that I stretch out away from equilibrium, the force, if I were to let go of it, is going to bring that spring back to its equilibrium position. If I have a spring that I compress from equilibrium and make smaller, when released, the force is going to push back towards that equilibrium position. So the negative indicates the force we're talking about is a restoring force. Now let's go ahead and do a calculation with Hooke's law. So the force that we have being applied here by the person in this downward direction is equal to mg, mass times our acceleration due to gravity. And then the restoring force of the spring, which is opposing that, that's what we see in Hooke's law represented as kx. And the negative is indicated in the fact that this is in the opposite direction to the applied force. So for our spring, once we displace it, these forces are going to have to cancel each other out, and that's how we can calculate the mass of the person that displaced this spring by 0.5 meters. Here we would have kx is equal to mg, and when we plug in our missing values, we have 120 times our displacement of 0.5 is equal to mass times acceleration due to gravity. And for this particular problem, we're going to estimate that value at 10. Although the actual value is 9.8 meters per second squared. Just to make the math easy so that we make sure we understand this conceptually, we're going to use 10 here. So to do the math on this, 120 times a half gives us 60, is equal to 10m. And when dividing by 10, we get 6 kilograms as the mass of our person who is displacing this platform by 0.5 meters. If you'd like more practice, please take a look at our other videos. You can visit our website at sandersontestprep.com, and thanks for watching.